Hello students, welcome to the online class of chemistry. So in today's session, we will be discussing about the theories of acids and bases. Okay, so first we have discussed about acids and bases. What are acids? Yes, acids are the substances that produces H plus ions when dissolved in water. And acid can turn blue litmus into red color. And also, they are having what? Sour taste. And what about base? Yes, base will produce OH minus ions when dissolved in water. And it has a bitter taste and also it will turn red litmus into blue. Now we will discuss about the theories regarding what acids and bases. So here you are going to study about three theories of acids and bases. The first one is Arrhenius theory. Okay, so Arrhenius theory was introduced in the year of 1884. It was given by Arrhenius. So according to this theory, the acids and bases can be explained using the ionization property. Okay, so according to Arrhenius, he said that acids and bases are having what? Ionization property. So that let us consider one acid, that is HCl. Okay, when you consider this HCl and you dissolve this HCl acid into water, it ionizes to form what? H plus plus Cl minus. As we discussed, acid will produce what? H plus ions. That is what Arrhenius said. So the definition which we are using for acid was given by whom? Arrhenius. Arrhenius said that acids will produce what? H plus ions when dissolved in water. And what about a base? Yes, as we discussed, NaOH. What is NaOH? Sodium hydroxide. The sodium hydroxide when dissolved in water, it produces Na plus and OH minus. Okay, so here acid is producing H plus ions and base is producing what? OH minus. That is what Arrhenius said. When you dissolve some substances into water, if they can produce H plus ions, then they are known as what? Acid, and base will produce what? OH minus ions when dissolved in water. Such type of acids which can produce H plus ions when dissolved in water is known as what? Arrhenius acid. What are they called? Arrhenius acid. So what is Arrhenius acid? That produces substances that produces H plus ions when dissolved in water is known as Arrhenius acid. And what about Arrhenius base? Yes, for Arrhenius base, we can say that the substances that produces OH minus. What is OH minus? Hydroxide ions when dissolved in water is known as Arrhenius base. Okay, that is known as what? Arrhenius base. Now you must have an idea about acid and base, right? So the definition which we are using was given by whom? Arrhenius. This theory was introduced in the year of what? 1884. So according to this theory, an acid produces what? H plus ions in water, and the base produces what? OH minus in water. So this Arrhenius actually divided these acids into separate what? Category, that is strong acid, weak acid, which we have studied in our previous class. That means in the classification of acids, we have studied about what? Strong acids, weak acids, strong base and weak base. So this classification was given by whom? Arrhenius. Okay. So what do you think? This theory is applicable to all the acids and bases? No, never. If you consider CO2, okay? If you consider CO2, that is carbon dioxide. This carbon dioxide has what? Acidic nature. That means that it will produce H plus ions? No. This carbon dioxide will not produce what? H plus ion, but it is having what? Acidic nature. These are the limitations of what? Arrhenius theory. What Arrhenius said? acids will produce H plus ions, but there are certain acids and bases. If you consider ammonia, what is ammonia? NH3. Is there any OH minus present in ammonia? No, there is no OH minus present in ammonia. But still, ammonia is what? A base. This clearly shows that there are certain substances which cannot produce as H plus or OH minus, but still they are what? Acids and bases. And also what Arrhenius said, acids will produce H plus ions only in the presence of what? Water. So this theory is actually applicable only for those substances which will dissolve in water and produces what? H plus ions or OH minus. So this theory we cannot what? Consider for the acids and bases. In all the cases we cannot consider. We will consider in your CBSE textbook also what you are following is H plus ions and OH minus ions. But this theory is not applicable for what? All the acids and bases. There comes our second theory. Okay, what is the second theory? Second theory is Bronsted-Lowry theory. What is that? Bronsted-Lowry theory. This theory was given in the year of 1923. Okay, this theory was given in the year of what? 1923. So, according to Bronsted-Lowry theory, this was completely based on proton transfer. What is mean by this proton transfer? That we will study. Okay, so Bronsted-Lowry theory is based on what? Proton transfer. So what is meant by this proton transfer? Now we will get to see. Okay, so here I am going to consider an acid and a base. Okay, so here I am just writing acid. Imagine acid will produce what? H plus ions. It is producing what? H plus ions. So this H plus ion was produced from where? An acid. And then this H plus ions will be accepted by what? A base. Can you see here? So here acid is producing what? H plus ions and base is accepting those H plus ions. That is what Bronsted-Lowry theory. According to Bronsted and Lowry, they independently proposed this theory. Okay. So according to them, an acid will produce H plus ions and base will accept H plus ions. Okay, acid will what? Donate H plus ions and base will accept H plus ions. Then where are these protons? Here I have said what? Acid produces H plus and base is accepting those H plus ions. Then who is the one transferring these protons here? Yes, H plus ions are also known as what? Proton. H plus ion is also known as what? Proton. How? I will show you here. Here you can see an atom. Okay, this atom is what? Hydrogen atom. In case of hydrogen atom, how many electrons are present in a hydrogen? Yes, in a hydrogen there is only one electron present in hydrogen. And how many protons are present in hydrogen? Yes, in case of hydrogen, there is only one proton because its atomic number is what? 1. The atomic number of hydrogen is 1. What is meant by atomic number? The number of proton or number of what? Electron. In case of hydrogen, there is only one proton and what? One electron. Just imagine that hydrogen is losing this electron. Okay? Hydrogen is what? Losing this electron. Right now, hydrogen has no electron and one proton is present in the nucleus. Yes, right. So if you consider hydrogen has one electron and one proton. When it loses one electron, how many electrons are present there? Yes, there is no electron present after losing that one. Then what about the proton? Yes, one proton is present in the nucleus of the hydrogen. So one proton, right? One proton is present. That is why it is known as what? H plus ions are known as proton. Understood? Okay, H plus ion means hydrogen will lose one electron. Losing electron means they'll gain which charge? Plus charge. Okay, because here one proton is present. What is the charge of proton? Plus charge. That is why we will put which charge here? Plus charge. Hydrogen has a plus charge. That means that it loses one electron and only one proton is present. So H plus are also known as what? Protons. Okay. So according to Bronsted-Lowry theory, Bronsted-Lowry acid means they are proton donor. They will donate what? Protons or H plus ions. And Bronsted-Lowry base means they are what? Proton acceptor. Did you understand the topic? So here, according to Bronsted-Lowry theory, the whole theory is based on what? Proton transfer. Proton means H plus ions. Okay. So here, acid, Bronsted-Lowry acid means they will what? Donate the proton and base will accept what? That proton. Understood? So it means that again there are what? Some confusions regarding this acid and bases, right? Here also they are discussing about what? The H plus ions. In the first one it was H plus ions and OH minus ions in the Arrhenius theory. And here they are speaking about what? The proton, that is H plus ions. Again you might have the same one doubt. If you consider SO2, that is sulfur dioxide. Sulfur dioxide is acidic in nature, but will they produce H plus ions? They don't have any hydrogen in them, right? So here SO2 cannot produce what? Any protons, but still they are what? Acidic in nature. And here calcium oxide is basic in nature, but will they accept H plus ions? No, they are not a proton acceptor. So this means that there are some limitations for which one? Bronsted-Lowry theory. Understood? So we have seen the first theory, that is Arrhenius theory. According to Arrhenius theory, an acid will produce H plus ion when dissolved in water, and base means they will produce OH minus ions when dissolved in water. And the second one was Bronsted-Lowry theory, where we have seen that an acid donate protons and a base will accept protons. Okay, now we will go to the third one, that is Lewis theory. Very important one. Okay, so both of them said that there should be hydrogen or OH minus should be there to confirm that whether it is an acid or base. But it is not always like that, right? But when you consider the subatomic particle, that is electron, electrons are present in what? All the atoms. Electrons are present in what? All the substances. So Lewis has proposed another theory that was completely based on electron pair transfer. It is what? Electron pair transfer. Okay, so according to Lewis theory, we can categorize acid and base according to what? The electron pair transfer nature. Okay, so here I am going to give you one example. First we will give a general example. Here I am considering a base. Okay, a base, if I consider, this base will give 2 electrons. Okay, 2 electron means we can say what? They are electron pairs. And then these electron pairs will be accepted by an acid. Can you see here? Base is giving what? 2 electrons. And acid is accepting those electron pairs. For example, here I am considering base as NH3. What is NH3? Ammonia, right? NH3 means it is what? Ammonia. Okay. In case of NH3, there is what? A nitrogen present in the ammonia molecule as a central atom. and there are what? 3 hydrogen atoms around the nitrogen. For example, you can see here, I'm considering this as the nitrogen, and this will be what? 3 hydrogen atoms. Okay, and in case of nitrogen, there exists a lone pair. Okay, there exists a lone pair. On the central atom, the electrons will delocalize to form what? Electron pairs. So this electron pair is known as what? Lone pairs. Okay, so NH3 has what? A lone pair in it. Now, we will consider an acid. Okay, that is BF3, boron trifluoride. In case of boron trifluoride, boron is the central atom and there will be 3 fluorine atoms around the boron. Okay, they want to have what? A bond between them. But boron doesn't have what? Any electron to share. But who is having extra electrons here? Nitrogen, right? In the ammonia, nitrogen has what? 2 extra electrons, that is the lone pairs. So what nitrogen will do? Nitrogen will share these electrons, okay, or give its electron to whom? To the BF3, and they will form a coordinate bond. They will form which bond? A coordinate bond between NH3 and BF3. This is an example of what? Lewis acid and Lewis base. So according to Lewis theory, a base is a substance that can donate electron pairs. So ammonia is what? Donating electrons toward the BF3, and they form what? A coordinate bond. Okay, so we can say that this NH3 is what? A Lewis base. Okay, this is what? Lewis base, and BF3 is what? Lewis acid. Okay, it will accept those electrons and it will become what? Lewis acid. Understood? So here we have studied about 3 theories of acids and bases. Okay, once again we will just see 3 of them. So the first one was what? First one was what? Yes, it was Arrhenius theory. Okay, Arrhenius theory. According to Arrhenius theory, acid donates what? H plus ions, and base will what? Produces OH minus ions when dissolved in what? Water. Water should be there. Okay, when dissolved in water, they produce what? H plus and OH minus ions. That is what? Arrhenius theory. Second one was what? Bronsted-Lowry theory. Okay, Bronsted-Lowry theory. According to Bronsted-Lowry theory, acid will give what? It will donate protons. Okay, acid is what? A proton donor, and base will what? Accept those protons. So we can say that it is a proton acceptor. It is a proton acceptor. Okay, so here we can take example as HCl. 1 minute. So here we can take example as what? HCl. HCl will produce H plus plus Cl minus, and base we can consider as what? NaOH, which will produce Na plus and OH minus. Now in case of Bronsted-Lowry, we can say that HCl, I'm taking HCl, okay? HCl will produce what? H plus ions. It will produce H plus ions. So this one will be what? The acid, and here we will consider H2 as what? Base. So H2O will accept this proton and it will become what? H3O plus. What is this H3O plus? Hydronium ion. Okay, along with that it will produce what? Cl minus. So here HCl is the acid and H2 is what? Base. Now we have the third one, that is the last one, that is Lewis theory. According to Lewis theory, acid is what? Acid is a electron acceptor. Okay. Wait a minute, it will come. So Lewis theory, that acid is what? Acid will accept an electron pair and base will what? Donate an electron pair. That's what we have seen in the case of NH3. So here electron pair acceptor. Electron pair acceptor, and base is what? Base is electron pair donor. What was the example we have seen? Yes, it was NH3. NH3 has two lone pair electrons, which it will give to what? BF3. So NH3 will be the base and BF3 will be what? The acid. So these are the three theories which is made on what? Acids and bases. Hope you all understood. Next we will see in the topic of what? Indicators. Thank you.